All right, so let's see. This is going to be a brief one, the definitions of the limits. So by definition of the limit, we look at the function. Okay, let me. One second. So by definition, okay, we're going to use the functions no matter what the function define for all x near the except near a, x near a, the x and the a, okay, except possible at a. So we will look at the value that's closer to the point a, okay? If x is arbitrarily close to L. So like two things. So we have y equals f of x, where x approaches the value a, y approaches the value L. That's okay in the chat. Yes, I will post actually the PowerPoint is the same as the class note, just in the bigger version, but I will post the recorded session. Sure, okay, I will post the PowerPoint. It's kind of the messy PowerPoint. It's fine. Yeah, I'll post everything. Okay, yep, whatever works. Yes, I will do it. Yes. Yeah, let me know if you need anything else. Okay. Maybe I clean up before I post so it will not look so messy. Anyway, so I will put in the easier way. For the function, we know we use the notation y equals f of x all the time, right? The short version of this definition is x very close to a. You see the two things. X close to a, the y is closing to the value L. So two things, x version and y version, x form and y form. So if we can say x approaching a, y approaching L, we put in the notation that limit of a function f of x, limit of the function, and the function, this is the y value, right? Limit of the function as x approaches a equals L, approaching a, y equals L, y approaching L. For example, you have the graph here, you have the graph. So this is x direction, and this is the y direction, and this is the x approaching a. So you see the graph, as you coming along the graph, x approaching a, the y approaching to the value L. Coming from the left, coming from the right, and we will talk about the one-sided limit later on. Okay, so this is a formal definition. Now, so if you see this notation, the limit of the function f as x approaches a, just a plain number a can be negative, can be positive, can be 0. Okay, this limit approaches value L. This version is called the two-sided limit. So what does it mean, the two-sided limit? That means coming from both directions on the graph. And we're gonna see the graph here, okay? So this example, the graph on the side here, y equals f of x, you see the hole, you see the jump, you see the dot above the curve somewhere here. So two sets. Part A, you're gonna use the graph here to find the function at 1 and the limit, the two-sided limit of the function where x approaches 1. That's how you call it, okay? Part B, f at 2, and then the limit as x approaches 2. So kind of three cases, two things you have to find for each case, the function value and the limit as x approaches that number from both sides. Okay, could you help me find the function value at 1 first? So we're gonna complete the function value. So this is the function value. From looking at the graph, could you give me the value of the function at 1? Anyone?
2.
2, okay. F at 1 is 2. How about f at 2?
3.
The function f at 2, that means when the function is defined, what is the value of that function? Where x equals 2.
Wait.
So when x equals 2,
Is it 5?
yes, that's the function value right there. So this is the f at 2 because it's defined. See the dot is up there. So f at 2 is 5. How about f at 3? Do you see any value of the function where x equals 3?
No.
No. So if it's not, well, it doesn't show on the graph. So we call, what do you call? Undefined. Do you recall that term? Undefined, right? Because the graph has a hole, so it's not defined. All right, for the function value, I'm sure you guys okay how to read it from the graph. Now we're gonna look at the limit. So the second step here is called the two-sided limit. That means you're gonna look at the particular point. For example, in part A, x approaches 1. So this is 1 right here, 1. And on the graph, you're gonna look at both directions. You move along the graph, okay? From the left side, from the right side, from both directions where x approaches 1. X approaches 1. What the function value approaching to? The value 2, right? I had to say 2. Can you see? When you move along the graph, from the left, from the right, the graph approaching to this number. You see?
Yeah.
Okay. So, and then part B, same way. Now we target the x equals 2, coming from the left side of 2, coming from the right side of 2. The function approaches to what number? You just look at the graph. What did you say?
I said 3.
Yes, the limit approaches 3. Now we look at the nature of the graph, the behavior of the graph for the limit value, okay? Which are different than the function value that you guys told me. All right, how about the last case? How about when x approaches 3? Now we look at the graph, move along the graph, coming from the left side, coming from the right side. If both of them coming towards the same number, we use that number to represent the limit of the function. So for x approaches 3, what would be the limit of the fx?
4.
Yes, gonna be 4. Gonna be 4. Now you look at these 3 cases. You see the first one, no hole, no gap. The function is the same as the limit value, right? The second case, you can find both of them. You can find the function value. You can find the limit, but they are not the same. They are not the same. All right, so question, which part did you guys don't understand?
I have a question.
Yes.
So, like when it's asking when x approaches 1, for example, is that basically just asking for the y coordinate?
Say it again, Leah.
Is it basically just asking for the y coordinate? Like for the first one, when it says when x approaches 1 from the left, and the answer is 2.
Yes.
Is it just
Yes.
asking for the y coordinate?
Yes. Not the y coordinate, the y value. See, the function f is the y. Yes. You are correct.
Okay. All right. Thank you.
So for x approaches 1, as x approaches 1 from the left, from the right. So what the function value? What the function value approaching to that value, not exactly the function value itself. You see the case in part A, the function value is 2. The limit also 2. Okay, but the second case, part B, the function is 5, the function itself. So that means you can plug the number in, or you can look at the graph. So the value is defined at 5 equals 5. But the limit you have to look from both sides of the graph. What would be the value that both sides of the graph coming toward to? So coming toward to the value 3. So this case is called discontinuity because the graph has a hole or has a jump, okay? Or when you move along, you're gonna lift your pen up and then keep going after you pass that point again. And then the last one, number 3, you don't have to know the function value, but you can still find the limit. So that means the graph approaching to that point, but you can omit that point as a function value. So 3 different situations that we're going to see from now on.